Now we're gonna solve the last two supplementary exercises, which you have to write down since I also wrote it down on a separate sheet. The following represents the table of time in weeks versus the number of microorganisms. How the number of microorganisms are changing with the change in the time period of storage in weeks 0, 4, 8, 12, and the respective change in the number of microorganisms. What we have to do is to determine D. In order to know how to determine D, we have to figure out what is the definition of D, or we have to put in our mind what is the definition of D. D is defined as the time to reduce the population of microorganisms by 90%. You can find this definition in the slide of 25. So what is the time we have? So we are looking for the time that is needed to reduce the number of microorganisms by 90%. For this, let us observe the change in the rate of microorganisms. 10 to the power 6, 1.1 times 10 to the power 5, 1.2 times 10 to the power 4, 1.2 times 10 to the power 3. Over here, we can spot a change from 1.2 to the 10 times 10 to the power 4 into 1.2 times 10 to the power 3. 1.2 times 10 to the power 3 actually represents 10% of 1.2 times 10 to the power 4. You can verify this by doing the rule of 3. يعني بنعتبر 1.2 times 10 to the power 4 هي 100%. 1.2 times 10 to the power 3, how much does it represent? It represents بيطلع معنا 10%. By this, we obtained a 90% decrease from this value to this value. Here, this would correspond the time that is taken in order to undergo this 90% decrease from this level to this level corresponds to D. We can directly get it out from the table over here. What is the time that was needed to go from this into this value? It is equal to 12 minus 8 equal to 4 weeks. Okay? So 4 weeks correspond to the time that is needed to go from this value into this value. It's not necessary إنه هلا لأنه إحنا عنا intervals of 4 يعني هي 4. Sometimes the time that is needed maybe it's from 0 to 12. So we minimize or we subtract the 12 from 0. يعني it depends when إحنا شفنا variation, a 90% variation. Where did we observe a 90% decrease from the initial to the end, from the initial to the middle? It is by chance that we observe this 90% decrease at the level of the two last respective value ranges. Okay? Now, example 6, it's also similar in order to understand more the concepts that we introduced in the chapter of rate of deteriorative reactions. Over here, we have a table showing the temperature change versus D, the decimal reduction time. Temperature change from 105, 107, voila. And decimal reduction time, the D value, which is the time needed to reduce the population of microorganisms by 90% as respective of a change of temperature. لأنه as we change the temperature, the decimal reduction time would change. We need to calculate Z. What is Z? If we recall for the slide 39, Z is defined as the temperature change. It is temperature change for the tenfold change in the D value. So we have to look over here. Where do we have a tenfold change in the D value? 100, 92, 80, 50. It is from 100 to 10. Over here, we have a 90% change in the D value. And this corresponds to what respective temperature? From 105 to 117. So by this, we subtract 117 minus 105. 17 minus 5, it is equal to 12 degrees Celsius. This is the value of Z.